Hi, welcome to DonskyTech. In this video, I am going to share with you how you can control your Arduino-based Internet of Things project using a database, particularly the MongoDB database. I have often been reading the following questions on message boards and forums regarding Arduino programming about how you can save your sensor data from your Arduino-based board to a database, or how they control their sensor or components from their Arduino projects using the database, or is it possible to log a real-time readings of your temperature sensors in your Arduino-based microcontroller like the ESP32 or ESP8266 to your database? In this post, I am going to share with you my personal solution to these questions and show you why MongoDB is a good database for IoT development. This video is part 4 of my MongoDB IoT tutorial series where I will show you how you can interface your Arduino IoT projects with a database. This series would integrate the popular MongoDB NoSQL database to your electronic circuits. We will be using Arduino-based microcontrollers, Raspberry Pi single-board computers, and MicroPython devices. Right now, I'm going to share with you a demo of my project. I have here my ESP32 microcontroller, a simple LED, a DHT22 temperature sensor, and a relay that is being powered by my bench power supply in here, running 12 volts. In the background of my laptop or workstation is my REST API server, which I have fairly discussed in the previous video about how you can create your own REST API server using Python. So if you have not yet read the documentation of this project or watch that video, then I highly suggest that you watch or read the documentation so that you would know how this REST API server was created and how it works. Right now, I am showing to you my MongoDB Atlas cluster, and I have pre-populated my sensors DB database with some sample record or documents regarding my key components. So as you can see, I have here a sensor ID which represents the LED, and I have one also for relay, and the other one is the DHT22 component. And for each document, there is an object ID that uniquely identifies the following document. As you can see also, the pattern or the format of the MongoDB is like a JSON. So there is a key and a value pairs like this, sensor ID, LED1. And there is also some difference in how the JSON data is being formatted. As you can see, the schema for the LED is different from the schema from the relay. There is a values component here that represents the in1, in2, in3, and in4, while in the HT22, there is a reading element that represents the temperature and humidity. Our Arduino projects in here periodically checks the latest value of the MongoDB database. So for example, in the LED, the value in here is high. If I turn this to low and then try to update in here, and the Arduino component is periodically scanning the values from the database. So as you can see, the LED turns off. If I turn it back on, like putting this into high, then click update, then you notice that the LED turns on. Regarding the relay, there is a value in here that represents the values that you can control for each individual relay. Since I have an active low relay, so it means that if I send a low signal, then it will turn on. As you can see, right now, everything is turned on. if I set this value in my database to high, and then click update, notice the sound done by the relay. All of the input turns off. So right now, everything is disabled, which means that if we are controlling an AC device, then everything will turn off. So let's try turning on the last two input. So I'm going to click this to low, then set this to low also, and then click update. And you notice that the relay automatically turns on. So right now I have also the DHT22 sensor document in here. And what is happening in the DHT22 sensor is that I am saving the last readings in my database. So right now, the values is 72.3 for the humidity and 29.10 for the temperature. If I click refresh, then you notice that the humidity becomes 69.59 and 29.7. If I try to hold my DHT22, then I am assuming that the humidity should go up. So let's try refreshing. And as you can see, the values indeed goes up. It's now in 71.4. Let's try one more refresh. It's now 86.19, which means that the latest values from our DHT22 sensor is automatically saved into our database. If you check the serial communication logs of our microcontroller, then you would notice the following being printed in our serial monitor, which means that our ESP32 microcontroller is successfully communicating with our REST API server. So I'm going to show you. So this is my REST API server. So right now I have here my ESP32 serial monitor at the right side, and at the left side is my REST API server running in Python. And as you can see, they are communicating with each other. And the job of the REST API server is to communicate with the database, and it passes the data back into our ESP32 microcontrollers. Would you like to know how I did this? Then let's start exploring. So, in the previous video of my MongoDB IoT tutorial series, I specifically mentioned that it is a good practice to create an API server that would directly communicate with our database. In return, our Arduino microcontrollers would then communicate with the API server. So, and if we want to interface or get something from our MongoDB database, then we talk to our API server. In this particular series, I have used Python programming language in creating the API server, as I feel that it is much easier to understand for IoT developer compared to other languages such as PHP or the JavaScript programming language. But whatever language you choose, the concept still remains the same, as we are particularly following a particular architecture called REST. REST is representational state transfer architecture, and this is how our API server is being created, which means that our Arduino microcontroller needs to send an HTTP request and handle the returning HTTP response from our API server. To be able to easily do this from any Arduino-based microcontroller, such as the ESP32 or ESP8266, then we can use the HTTP client library to send for us the request and the response object. Using HTTP client, we would send an HTTP request with a specific method to a REST API endpoint. So, in this diagram, I am sending a GET request to the endpoint /API/sensors. As I have mentioned in the previous video of this series, we have created several API in our sensors management system that will allow us to execute code or create, read, update, and delete operation to our database. The API server is programmed to send back a JSON object or a JavaScript object notation object, and whatever the response is being sent back to our Arduino microcontroller. The Arduino microcontroller then parses the values coming from the JSON response and controls our component. For example, in this diagram, if the status of our LED is low, it means that we will turn off the LED. If it's high, then we will turn it high. 10 points are we talking about here? In the previous video, we created a REST API endpoints that will allow us to execute CRUD operations to our MongoDB database records. But for this project, we are only interested in two endpoints below, which will allow us to send a GET request to the following API endpoint, and it will return to us a JSON response. So for the GET request, we are sending it in the /API sensors, and then we have a parameter called sensor ID, and the name of the parameter is LED1, which maps directly to our MongoDB database records. When we send an HTTP request to this endpoint, then it will give back to us the sensor information in JSON format. The other values is the put endpoint, wherein we send an HTTP put to this /API sensors, and we pass in the ID or the MongoDB object ID, which in this case in here for the object ID of our DHT22. What this put request is doing is that it will update our sensor records. Particularly, when I send an HTTP request, I am passing the JSON object called readings so that we can update this particular record and save the latest readings for the temperature and humidity. So this is the wiring and schematic diagram of our project. Take note that in my project, I am using the 12 volts relay. So that's why I have here an external power supply to power the relay coil. It's also a good practice that when using a relay, we should separate the load circuit from the trigger circuit so that they are isolated. So this is the summary of the wiring and schematic diagram. As I have mentioned, I have separated the load circuit from the trigger circuit, so that's why you need to remove the JD-BCC and BCC jumper and connect it to our bench power supply. So let's now go into our project. First, we need to check our platform INI. By the way, this project is available in my GitHub repository. So if you wanted to check out how this project works, then please see the description of this video. The libraries that we're going to use is available in the platform.ini file, which is the standard configuration file of the platform IO IDE. I'm using Visual Studio Code in here to program my project. So we're using the Adafruit, the HT sensor library, and the Arduino JSON so that it is easy for us to create and send JSON requests to our REST API server. And at the same time, we can parse the JSON back into our microcontroller. The main logic is in the main.cpp, which you can see in here. And let's try to scan what each line of the code does. So The first one is to import the necessary header files needed to connect to our REST API server and our DHT sensor. Next, we need to change the following variables to match your network credentials and set also the IP address of your REST service. So in this case in here, this IP address is mapped to my running in the background API server. So if you have set up your own REST API server, then you need to match the IP address in here. Next, we need to define the HTTP client and the Wi-Fi client in order for us to call our REST API endpoint from our ESP32 or ESP8266 board. Then, we need to define the following values like the read interval or the delay. So, our Arduino project is periodically sending API requests to our API server every 5 seconds, which means that the REST API endpoint is being called to retrieve the MongoDB database record every 5 seconds. Next, we assign GPIO pins that are connected to our LED relay and our DHT sensors. Once we retrieve the records from our database, then it's time to map it to our Arduino code. In this case in here, I have used the struct for the creation of the data structure so that it is easy to return multiple records back into a calling function. For each particular record like the LED, I have mapped or created this struct, and for the relay, there is an in1 or in2 also, and there is for the DHT, there is a temperature and humidity. Next is the code that will allow us to send an HTTP GET to our REST API server. The first thing that it is doing is that we format our REST API server so that we would know that we are going to call these API sensors and we will pass in the sensor ID in this case. So I'm using the sprintf command. Once we have know or created the endpoint, we will just call the HTTP GET. And then once the HTTP GET is finished or sending the request, then it will send back a response. So we need to deserialize back the response into a JSON object. We call this method for the deserialized JSON in the Arduino JSON project. Once everything is okay, then it is sent back to the caller. As you can see, I have a method here for the extract LED record. So whatever the response from the HTTP call HTTP GET is then checked if the size is null or the size is greater than 1 because we are only expecting 1. Once everything is okay, then we need to look for the array and we need to extract the values for the LED. Once the LED is created, then we need to use this particular method, which is creating a local LED struct and copy the values into these values or the array in our struct. Next, there is a record for the extract relay configuration, which is almost the same. From the LED, we just call the HTTP GET and then pass in a different sensor ID. Since the structure of the schema of our document is different for each sensor, then we need to particularly extract the values for the relay differently from the LED. The same thing also, we need to send back an object or a relay struct to the calling functions. Next is our send DHT22 readings. It's almost the same. We need first to create the API sensors and then we need to pass in the object ID because in the REST API endpoints, it is expecting an object ID object. Next, if the endpoint is already created, then we need to prepare our JSON data. So the JSON data will come in from our DHT readings, which is the temperature and the humidity. And we need to serialize the object into a string so that we can send it to our HTTP request. Once everything is okay, then we just need to send the HTTP put. So as you can see in here, it says HTTP.put, and then we send the JSON data together with it. Once the response code is okay, then what we're going to do is to serially print it, and then we end the connection. This function is the read-ht22, which just basically use the Adafruit library to read the humidity and the temperature readings in our sensor. I have here certain utility functions that I am using for the program, and I have commented it so that you would know how it works. But for this convert status, since we are saving the values as string in our database, so we compare if it is high, then we return the Arduino value here called high. Then if it's low, then we return the value low. And then for the set LED status, we just set the LED status by printing calling the digital write. For the relay, it's the same also. We call the digital write with a pin. And then I have here a turn off relay, which basically just turn off our relay during startup. The setup function is the usual Arduino function wherein we connect to our Wi-Fi. And then once we are connected, we start communicating with our DHT sensor readings, and then set the pin mode for all the LED and the relay, which we have done in here, and turn off the relay during startup. In the loop, this is where we have an interval. As I have mentioned, the read interval is 5 seconds. So we are not using any delay. We are not using any delay function in here so that our microcontroller can continually function normally. So for example, in here, there is a serial.print line that I have added here just for us to easily see what is happening. So for the LED, we call the function struct LED configurations, and we pass in the sensor ID, which is LED1. Once we have received the struct, which is populated with the values, then we serially print it. And then whatever the values in the LED setup status, we convert it back into a high or low, and then we set the LED status. The same thing also for the relay. We just call the extract relay configuration, passing in the relay1 sensor ID, and whatever the response, we convert it back into the applicable format and then set the relay status for each particular pin. And for the DHT sensor, what we're doing is we first read the readings from our DHT sensor. If everything is okay, then we just continue. Next, after reading that value, then we need to send the DHT22 readings. And as you can see, there is an object ID here. So if you're going to do this in your local environment, then you need to copy first the object ID from the DHT sensor and place it here before you upload this program into your microcontroller. So that is actually how this program works, and using this code, you are able to control anything using a database in your Arduino IoT projects. It's cool, right? See, because the data right now is available in our database. So in future projects, what you can do is that you can add an external web application that will display the values coming from your database. So for example, if the microcontroller is continually sending the DHT sensor readings in the database, then we can have an external application that will display the values in graphical format. At the same time, we can add a switch here that we can trigger so that we can control the LEDs and our relays. So if there's a need for you to change the values in your electronic circuits, then what we're going to do is just communicate with the web application and then set the values in the database, and our microcontroller will continually query our database using the REST API server. Maybe if I have time in the future, I will do this one. So that's all for the code and the description. The write-up for this project is available in the description of this video and including the code if you wanted to check it out. So, this is the end of our project, and if you have any questions or any trouble running the code, then I highly suggest that you add comments in the comment section of this YouTube channel or in my blog post, which you can find in www.donskytech.com. The code, the write-up is available in the description of this video for you to check out. I hope you enjoyed this presentation and you have learned something that you can apply into your daily IoT lives. Happy exploring!